Let's take a look at what's called a telescoping series. Here's my wonderful drawing of a telescope. Let's go show an actual picture real quick. So here's a picture of an old-fashioned piratey kind of telescope, or three of them at least. So that's what we're thinking of here, where you can push the two ends together and it all kind of collapses down to just one small cylinder. So what does it mean for a series telescope? Let's try a series like n equals 1 to infinity, e to the 1 over n minus e to the 1 over n plus 1. Now this is a little bit silly of a series, but there are other telescoping series that happen in the homework, so we'll just go with this one for now. What happens at n equals 1? What's a sub 1? It's e to the 1 over 1 minus e to the 1 over 2. You take the 1 from n here, plug it in there, you get 1 over 1 plus 1, which is 2. Let's think about n equals 2. What's a sub 2? It's e to the 1 over 2, to copy the n there, put it there, minus e to the 1 over 3. And let's do n equals 3, a3 is equal to e to the 1 over 3 minus e to the 1 over 4. Now let's think about the partial sums. What is s sub 1? Well, that's just a sub 1. That's just that. What is s sub 2? That's a sub 1 plus a sub 2. And what happens if I add this a sub 1 with this a sub 2? You might have noticed already that the minus e to the 1/2 cancels the positive e to the 1/2. So let's draw a wonderful canceling bubble there. And what do you get? You just get e to the 1 over 1 minus e to the 1 over 3. And then what happens if I say what's s sub 3? That's a1 plus a2 plus a3. And that would be this plus that, and that cancels, plus this, e to the plus a negative e to the 1 over 3 plus e to the 1 over 3 minus e to the 1 over 4. So that ends up canceling too. So we get e to the 1 over 1 minus e to the 1 over 4. So what would you guess the formula for the nth partial sum is? Does it look like each thing here would cancel with part of the previous term, and we would just be left with this first part, e to the 1 over 1, minus whatever this last part is. And here at n equals 3, that was e to the 1 over 4, because it was 1 over n plus 1. So it would be e to the 1 over n plus 1. So can you see how this is related to this idea of something where the cylinders kind of collapse in on each other? So now that we have a formula for the nth partial sum, we could say the infinite sum is the limit as n goes to infinity s sub n, which is the limit as n goes to infinity, and we know what s sub n is. It's e to the 1 over 1 minus e to the 1 over n plus 1. And what's that limit? Well, e to the 1 over 1 is just a constant, so we can just copy that out here. It's an additive constant in this case. And then minus, what do we get here? We'd get e to the 1 over infinity plus 1. I'm going to kind of put that in quotes. We shouldn't really write that, but that's basically what's happening. So what is infinity plus 1? It's basically infinity. So we get, I'm going to simplify e to the 1 here, minus e to the 1 over infinity. We'll put that in quotes. 1 over infinity, what is 1 over infinity? Well, it's like 1 over a million, 1 over a billion, 1 over a trillion. 1 over a million is 0.000001, maybe I missed an O there. 1 over a billion is and then like 8 zeros and then a 1. 1 over a trillion is like 11 zeros and then a 1. So 1 over infinity would be infinite number of zeros and then a 1, right? Which is basically 0. So this is e to the 1 minus e to the 0. So does this series converge? Well, we got a finite answer here. So the series converges. And we even know what it converges to. We could simplify a little bit and write e to the 1 is just e to the 0 is 1. We're not all that interested in the final answer here, but the point is telescoping series, everything collapses so nicely. You're just left with the partial sum is the first term plus, or in this case minus, the last part of that last term, and that makes it easy to say how is the partial sum behaving as n goes to infinity. And here's the surprising thing. The fundamental theorem of calculus is actually a continuous version of telescoping sums, because taking derivatives is like doing the y value here minus the y value here divided by delta x, and then you're adding to that because you're integrating the y value here minus the y value there, and so you get y values canceling all the way along. So let's write that down. Fundamental theorem of calculus. We're not going to use the fact here in Calc 2 that the fundamental theorem of calculus is basically a continuous telescoping sum, but it's a nice link. All right, so that's telescoping sums.